study the generating function for Laguerre function. Generating function for generating function for Laguerre function. Alright, Laguerre function. So if we see 1 upon, it says 1 upon 1 minus t e to the power tx upon 1 minus t is equals to summation n tends to 0 to infinity t to the power n ln x. So if we expand both the terms, when we compare t to the power n coefficient on both the sides, we will see left hand side will give me the Laguerre function ln x. Alright, so just to prove this, just upload on taking LHS. Just we are taking LHS. So our LHS is 1 upon 1 minus t e to the power minus tx upon 1 minus t. Alright, now this is e to the power something. So we know e to the power x is 1 plus x square upon factorial 2 plus x cube upon factorial 3 and so on. So I can write in a summation form like e to the power x can be written as summation r tends to 0 to infinity x to the power r factorial r. So I can write this term as in summation form. Alright, so I can write this is as it is 1 upon 1 minus t 1 minus t. This can be written as summation r tends to 0 to infinity r tends to 0 to infinity x, here x is our this whole term 1 upon minus t of 1 minus t to the power r into 1 upon factorial r. So this can I can write this term in summation form. Alright, so just rewrite this as here and summation r tends to 0 to infinity. So I can write as minus 1 to the power r t to the power r x to the power r upon factorial r, and I can write it as 1 minus t to the power r. Good. Now I can see 1 minus t and here 1 minus t, so it becomes r plus 1. So this is summation r tends to 0 to infinity 1 to the power r t to the power r x to the power r upon factorial r. I can write 1 minus t to the power r plus 1. Alright, now I can write this as summation r tends to 0 to infinity minus 1 to the power r x to the power r t to the power r. I just separated x and t factorial r. I can write 1 minus t to the power r plus 1. Now I need to open this expansion, so I know 1 minus x to the power minus n can be written as can be expanded as 1 plus nx plus n plus 1 upon 1 dot 2 x square plus n plus 1 n plus 2 x cube upon 1 dot 2 dot 3 and so on. So I can expand this binomial as this formula on behalf of this formula. Alright, so summation r tends to 0 to infinity minus 1 to the power r x to the power r t to the power r upon factorial r. This can be written as 1 first term 1, here n is our r plus 1 plus r plus 1. Now here x is t plus r plus 1 r plus 2 upon fact 1 dot 2 is converted in factorial 2 t to the power 2 plus so on. Alright, now summation r tends to 0 to infinity minus 1 to the power r x to the power r t to the power r upon factorial r This can be written as summation. This is all. This is here. I can write factorial 1. So this is factorial s. This is because here factorial 0 can be written, so I can write factorial s. So s can vary from 0 to infinity. And here this term r plus 1 can be written as r plus 1. R plus 1 in factorial form can be written as factorial r plus s upon factorial r. Factorial r. Alright. Now what second term is t to the power s. T to the power s. So this can be written as this. Alright. So next is our just take the summation sign common. R tends to 0 to infinity. Summation sign s tends to 0 to infinity. Here we have 1 to the power r x to the power r t to the power. Okay, t to the power can be written as t to the power s plus r. And here factorial r square can be written as this. And here factorial s and one quantity r plus s. Alright. Assume s plus r is equals to n. So s can be written as n minus r. Alright. So we can say our n can from 0 to infinity. And now here summation side inside. This quantity becomes 1 minus r is here. Factorial r x to the power factorial r here. N plus s is a factorial n. And here upon factorial r square factorial s can be written as n minus r, n minus r, and t to the power n. This is so now I can see our s. Sorry, our r can vary from r here. R can vary from 0 to n only. Why n? Just because it can't be negative, so the maximum value can be n, value of r. If this goes higher than n, so the factorial becomes negative. So factorial can't be negative. So for that, the maximum value r can take is from 0 to maximum n. So I can see this is our summation n equals to 0 to infinity. It is t to the power n, and this is our ln x. Alright. So in last lectures, I think in our differential equation I had written in infinity. So please do check. This will go from 0 to n only. Alright. So this is our generating function. So now expanding our left hand side and comparing the coefficient to the power n, we will give this equation will give us our Laguerre function. So this is our generating function. Generating function. Alright. So please do check this video. Thank you.